Hi guys. We're going to continue today basically with just two more monster problems. So I'm actually going to even call it example number 3 since we're continuing from yesterday. Let's just jump right in. Here's our example for today. It says 3x to the third minus 7x squared minus 14x plus 24. And then we're going to answer just a huge list of questions. So this is like every question that I could ask you about this polynomial. We'll start with, let's make sure the polynomial is in standard form. Can't really do anything else if it's not in standard form. And this one already is. So standard form, remember, is descending order according to the exponents. So it's already x to the third, squared, 1, and then 24. My next question for you is, let's name the polynomial. So I'm looking for vocab words based on first, its degree, and second, the amount of terms it has. So for the degree, we look at the largest exponent, which is a 3. And so I'm going to call this a cubic. And for the number of terms, we count how many terms there are. This problem has 4 terms. Anything with more than 3 terms is a polynomial. So this is a cubic polynomial. That's also going to help us with our next question. And our next question is, how many roots does it have? Remember, roots is just a fancy word for answers or solutions or x-intercepts. We're not going to be graphing today. Since this is a cubic, which means the largest exponent is a 3, it has 3 roots. So when I do solve this, I will expect to get 3 answers. Okay, this is something that we learned new on Wednesday, list all of the possible rational roots. So then we're going to list all of the numbers that are factors of 24. Now, every problem that we've done like this before has always had a 1 as the leading coefficient. That means that the first number in the problem was a number 1. But today we have a number 3 as our leading coefficient. So today it's actually going to get a little bit trickier than just listing off the numbers that multiply to 24. But let's go ahead and do that. So 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Okay, so definitely want those numbers in my list, and we stick a plus or minus sign in front of them because they could be a positive version or a negative version. Now, when you have a leading coefficient that is not the number 1, we also could possibly get fractions for answers. So the way to tell what your fraction answers are is you take all of these factors that you found for 24 and you divide them by the front number, 3. So I'm also going to add to my list 1/3, 2/3. I'm not going to do 3/3 because 3/3 is just 1 and we already wrote the number 1. 4/3. I'm not going to do 24 over 3. 24 over 3 can simplify to the number 8, and we've already written the number 8. It was one of the original red numbers. Same thing with 12 over 3. 12 divided by 3 is 4, so I can kind of skip over that one. 8 divided by 3, though, that does not divide evenly, so I would include that fraction in my list. And then 6 divided by 3 is 2, and I had already included that as one of my red numbers. So again, the red numbers are all of the factors of 24. 1, 2, 3, 4, 6, 8, 12, and 24. And then I do need to add fraction options to my list because of this front number 3. And so I'm adding fractions of 1/3, 2/3, 4/3, and 8/3. All of the other fractions simplified to a whole number that I already had in my list. So that's something new today. All right, the next question says, write the polynomial in factored form. Now, I can't just stare at it and do that. So I'm going to have to switch to a completely blank screen and we'll work on factoring this. Now, this problem, as it stands, maybe I can factor it. Maybe I can't. I'm thinking I probably can't, just looking at it. And so if you can't factor it using one of the methods that we learned during our factoring chapter in first semester, then what you do is you take that list of possible numbers and you plug them in until you get a number that tells you an answer of 0. And the first number that told me an answer of 0 for this problem was the number 3. So I tried 1, it didn't work. I tried 2, it didn't work. 3 did work. Once you get a number that works, you're going to do synthetic division using that number and the problem. And that'll take this from a cubic down to a quadratic. Now this is factorable using Xbox. If you'd like to see examples of Xbox, ask me to do them in class. This one does require you to do the box, again, because there's a 3 in front of the x squared. When I'm done, I get 3x minus 4 and x plus 2 as my two parentheses. Next, since this is equal to 0 and I'm trying to solve, I'm going to set each of these equal to 0, and the first parentheses will give me an answer of 4 over 3. And the second parentheses will give me an answer of negative 2. Now, that's not actually what that problem was asking. The problem was asking, write this in factored form. So I do have factored something on my screen right now, right? I have a 3x minus 4 and an x plus 2, but that was not the original equation. There was actually a little bit more to the original equation. So if this problem has 3 answers, in my factored form, I should also have 3 parentheses. I do have my parentheses from these 2 answers, but what I'm missing is my parentheses from this first answer, the x equals 3. So I'm going to add that in front as an x minus 3, because remember, we move it to the other side, we change the sign. And here's my factored form. Okay, so my factored form of this polynomial is x minus 3, 3x minus 4, and x plus 2. Let's go back to our other list. Write the polynomial in factored form. Here we go. Again, because this is an x to the third, it's important that we had our 3 parentheses. It's also important that we have our 3 parentheses to find our 3 roots. And we had already done that on the previous slide. Our 3 roots are, and I wrote them in numerical order, smallest to biggest this time, negative 2, 4/3, and 3. And look, all of those numbers were in our list, right? Here's our negative 2. 4/3 is over here. That was something new we learned today. And then 3 was right here. This concludes our monster problem number 3. We have one more monster problem.